Namaskar, my dear friends. Let us talk about function generator, which is XR2206. This is one of the most popular IC that is being used for past decades. And you can see this is a design and development board, and this is the IC. We have a lot of things that we will discuss in this particular session. So first of all, we'll try to understand what are the functionalities or what are the things that we can do with this function generator. So let us say you need to have a square wave generator or sinusoidal wave generator, or you need to generate some triangular wave. So this particular IC, which is XR2206, so this is capable of generating all these three kinds of waves from 1 hertz frequency to 1 megahertz frequency. Okay. So first let me list out what are the things we will discuss in this session. So this is the design and development kit that is readily available from many of the vendors. So we'll try to understand what is the design and development kit details, and then we will see the XR2206 IC design and details. So very quickly, if we try to understand what is the features and application of this XR2206 monolithic function generator. So this is from datasheet. So as you can see, it has low sine wave distortion, very low. So it is just plus minus 0.5% typically, and it has very excellent temperature stability, which is 20 ppm per degree centigrade. It can give you a wide sweep range, which is going to be up to 2000:1, and it has very low supply sensitivity, which will be just 0.01%. Okay, so it means like there will not be variation in the output waveform amplitudes, and it will be just varying by 0.01%, which is less than 1%. Okay, it has the capability of amplitude modulation, frequency modulation, all those things. It is capable of TTL compatible, means it is capable of your 5 volt logic as well as like a 3.3 volt logic, which will be for CMOS. And then it has a very wide supply range, which is going to be up to 10 volt to 26 volt range. And the best thing is it has a adjustable duty cycle capabilities as well, which is going up to 1% to 99%. So this is like almost 0 to 100%. Okay, so duty cycle you can change based on the requirement. So let us say this was my square wave, so you can generate like a lower duty cycle and like that, or otherwise if you want you can generate higher duty cycle as well. Okay, so whichever way you want you can do that. What are the different application of this particular IC will be? So that is nothing but a very important thing, which is waveform generator, that is going to be of like a square wave or rectangular wave, that is square wave and rectangular wave, or sinusoidal wave, and we have triangular wave, right? It can generate some sweeps as well. The most important thing is it can be used for your amplitude modulation and frequency modulation generation signals. Okay, and it has a voltage to frequency conversion as well. So from voltage to frequency conversion, it means it can be used for your analog modulation also, angle modulation as well. Then it can be used for your frequency shift keying generation and VCO, that is phase lock loop voltage controlled oscillators also. So these are the very like important features and applications that were there for this particular function generator IC, which is XR2206. If you see the board availability in the market, so this is the particular board that is there available, and this is designed already. So it has three like kits is there already. You can see these are the knobs that is actually used for adjusting the amplitude and frequency, and like frequency is having two settings. One is fine setting, one is coarse setting. Coarse setting means like little bit higher range you can set, and fine will be making it very closer. Okay, this is a particular IC that is there. We have the adapter input here. Okay, so this is the adapter that can be connected. Let's say you are connecting a 9 volt adapter, or maybe let's say 12 volt adapter. So both of the adapters you can try to utilize and connect it. And the best thing is it has three outputs that you can see here. So this will be used for your taking the waveform output. Okay, and this is the particular IC that I already told you. There are different views that has been shown here. You can see from this particular manufacturer that it has given a very good package with like a lower view and like top view. Both the views are there. So this is also called as XR2206 high precision signal generator development kit. Okay, so you can see some of the waveforms that has been generated as a as an example. So 1 kilohertz square wave signal, 1 kilohertz sinusoidal wave signal, and 1 megahertz square wave signal is there. Very little distortion you can see. 1 kilohertz is very good one. Then triangular wave, then 50 hertz sine wave. So there are a lot of examples that has been given already. If you want, you can get this particular board directly from robo.in. Okay, so robo.in will give you this particular board directly, and this cost I think less than some 600 rupees. Let us get into the features and specification of this particular board, which is XR2206 development board. Okay, so as you can see, this function generator can work from 9 volt to 12 volt. Okay, then it can generate your square wave, sinusoidal wave, and triangular wave from 1 hertz to 1 megahertz. The amplitude of waveform can be in the range of 0 to 3 volt. Okay, and it is also called as high precision waveform function generator. And the function generator, as I already mentioned, that it can give you from 1 hertz to 1 megahertz. It can be used for it can be used as a frequency and amplitude adjustment of the waveform also. And as you can see, for frequency adjustment, it can support both coarse adjustment and fine adjustment. Fine adjustment means it can make you very like closer to your required parameters. If you see the board specification, this is the model that is called as XR2206. The operating voltage range is mentioned, which is 9 to 12 volts. If you are buying the board, then you have to get into these details. Otherwise, from directly IC, you can develop your own board and no need to go ahead with all these specifications. Also, going back to this operating frequency, we already mentioned 1 hertz to 1 megahertz. The supported waveforms that will be there is sine waveform, square waveform, and triangular waveform. Your own design customized waveform will not be possible. The amplitude of waveform will be 0 to 3.0 to 3 volt, and distortion is less than 1%. Okay, it has a very good flatness, which is 0.005 dB, and that's all. So as you can see, this is the particular IC that I was talking to you. Now let's get into the IC details. So since we have already seen this particular, like board and its detail and how to, like do fine adjustment, coarse adjustment for frequency, for amplitude. So now we are into a position to understand the functionality and design and detail of this particular dataset. So let me open the dataset for you. As you can see, we have already seen the features and application of this particular IC, which is XR2206. There are different packages that is available from this particular IC, which is XR2206P, which is going to be 16 lead. Okay, and this can work from minus 40 degrees centigrade to 85 degrees centigrade. So this is the highest like range that is available. If you go ahead with little bit lower one, so that you have to do CP, and then with D it is also 0 to 70 degrees centigrade. Okay, so this D is SOIC package and this CP is PDIP package. So I have always preferred this one, which is XR2206 CP, which is lower temperature range. However, it will be lower cost as well. And if you want to go ahead with little bit higher temperature range, then you can go ahead with this particular first one, which is XR2206P. Now, if you talk about block diagram is very simple. So we have timing capacitors that will be used at pin number 5 and 6. Then we have timing resistor, which is TR1 and TR2. Then there are FSKI and AMSI. Okay, so like frequency shift keying input and amplitude modulated signal input. We have a waveform A1, A2, then we have system 1, system 2. We'll talk about the pin configurations as well. We have multiplier and sine shaper. Okay, so this is the thing. And then we have synchronized output as well at pin number 11, you can see. and we have a voltage supply, ground, and bias supply. So these are the things that is there. Very simple circuit in block diagram, as you can see here. If you talk about the pin configuration, so pin configuration is like that. Just now we talked about this is 16 link package in PDIC package, like this is through hole package, and this is SOIC package, which is also called as SMT package or SMD package. Okay, so this is surface mount packaging. If we talk about pin description, quickly we'll go ahead with pin description. So AMSI is nothing but amplitude modulating signal input. Okay, then we have STO, that is sine or triangular wave output, and MO, that is multiplier output. Okay, so these are the two outputs that is there, sine and triangular, as well as this is multiplier is nothing but a square wave output you will get at that particular pin, which is pin number 3. We have VCC pin, which is power supply pin. We have TC1, that is timing capacitor 1 input and timing capacitor 2 input. We have resistor, which will be used for your timing, and resistor 2. So 2 capacitors and 2 resistors are there to do the timings, right? We have frequency shift keying input, and we have internal voltage reference, which will be at bias voltage. We have sync output, that is synchronized output. This output is open collector and needs a pull-up resistor to VCC. Okay, and we have waveform adjustment input 1, then waveform adjustment input 2, and we have wave symmetry adjust 1 and adjust 2. So this is how the pin configurations are set. Now we have already seen in various ICs, like what is the DC characteristics, like single supply voltage range, that will be like 10 volt to 26 volt it will be required. So you have to attach a 12 volt adapter, so that will be like better. So as you can see, we have VCC 12 volt mentioned here also. Then this is how we will be working up. Now maximum operating frequency you can see. So minimum operating frequency is like 0.5 hertz or 0.5 megahertz to 1 megahertz. So that's, we have already talked about it. Coming back to the particular thing which we want to talk about is circuit. Okay, so basic test circuit, as you can see here, we have triangular sinusoidal output, and then we have a square wave output at pin number 2 and 11, right? And we have this particular resistor which will be used for giving it as a kind of load. You can understand this is kind of pull up that you can see. So this is pull to VCC. Okay, and at the same time there are like potentiometer or like variable resistor that you can utilize to set the output voltage amplitude or something like that. That's the reason you had seen in the development board also that there were adjustments. So those were actually nothing but some encoder kind of thing which we are trying to reduce or increase the resistances. Okay, based on that, amplitude and frequency will be changing for the output signal. And we have timing capacitor, as you can see, between pin number 5 and 6. So between 5 and 6 you can connect this particular capacitor, which will be, let's say 0.47 microfarad, or let's say 0.1 microfarad, based on like a little bit of calculation and all, we'll see in the data sheet. And at the same time we have timing capacitors, which is R1 and R2, and this is the power supply, which will be VCC. I'll suggest you to add here, let us say 10 microfarad capacitor plus 0.1 microfarad capacitor. Okay, so these are the two things that you can add extra. Okay, symmetry adjustment we have already seen. Then we have thermal like a third order distortion. So that total harmonic distortion is also there, THD. So this is called total harmonic distortion, that can also be adjusted. Now let's talk about other circuits that is available with us. So we have like a peak output voltage. There are some characteristics that is given. So for triangular wave, this is sinusoidal wave. So that is nothing, I mean we don't have to get into these parameters right now. Or otherwise, if you want to understand, let us say output amplitude versus function of resistors, okay, R3. So what happens is, as my resistor starts increasing, the peak output voltage also starts increasing, that you can see. Okay, Now, R versus oscillation frequencies also is there. Like if you want to have timing resistor, like what is the frequency that you need, right? So for that purpose, you can connect, let us say, 10 kilo ohm resistor at timing capacitor. Then you will be having, let us say, around 10 hertz or like less than 10 hertz frequency. If you want to connect a little bit lower capacitor, lower resistor, then it can go ahead with higher frequency setting. Okay. So the output frequency setting will be based on the timing resistor. Okay, so this was all about this. Now coming back to the test circuit that we had generated. So this is the application circuit that is there, which is called as circuit for sine wave generation without external adjustment. Okay, so if you want to have sine wave generator, sine wave output, so what is going to happen? We need to just have one timing capacitor, a timing resistor that is there. This was timing capacitor. This is a voltage supply. As I already mentioned you have to put 10 microfarad and 0.1 microfarad capacitor. Now simply you have to just have a switch. You can like directly connect it with this 200 ohm, and this one closed for sine wave. This is what it is telling you. Okay, so what we can do is we can keep one jumper here, and that can be removed and put back, so that you can have sine wave and as well as a square wave output also for other configurations. Okay, so this is very simple circuit that is available to design. There are other parameters also. So the best thing is this particular IC has given you almost all the output settings by what is the like R3 determines output swing. So which is the R3 that you can see here. This is R3, right? So as I already mentioned in the first page itself, this is the particular potentiometer that will be used to adjust the amplitude of the output waveforms. Okay, so if you want to increase or decrease the output of waveform, this will have to be accordingly increased or decreased, right? So that's all about this particular IC that you can see. The rest you can go ahead by yourself if it is there. And there are some of the like a triangular wave generation, or let's say frequency of operations. As you can see, the output frequency will be nothing but 1 by RC. So R was timing resistor and C was timing capacitor. So based on these two values, you can calculate theoretically what will be your output of the frequency, output waveform frequency. So if you want to have a particular like frequency output, based on that you have to adjust your resistor and capacitor settings. So as you can see, you have to make sure that my resistor is not below 10 kilo 4 kilo ohm and more than 200 kilo ohm. So my resistor must be 4 kilo ohm to 200 kilo ohm, and my capacitor must be 100,000 picofarad to 100 microfarad. So these are the two things that we have to keep in mind. Now if you talk about this particular understanding, like as we already saw, like pulse and ramp generation, then this is amplitude modulation. So that's all. So coming back to the packaging, so as we have already told you that this is a through hole package, and one more is SDIP package, that is your SMD package, which is your SOIC package. So alright guys, hope you have a good understanding about this particular IC which we just now talked about. And if you do have any question regarding the waveform generation and what is the values of resistor capacitor that is required to generate your particular waveform, that you can always put down your queries in the comment box, and we shall be able to give you exact values of RC values so that you can have a particular required design at the output. And how to develop this particular board also, that also you can like learn very quickly. So this particular board is designed already by many manufacturers, or many vendors are there available, so you can directly get it from them. Otherwise you can develop your own board. So this is very useful for the students projects, or like college students, and even many professionals are utilizing for this kind of function generator to give some inputs, or like taking some output for their particular industrial requirements. So thank you so much.